everyone, my name is Abigail P. Amasio, and our topic for today is all about graphing irrational functions. So let's begin. In this problem, we need to graph this irrational function. Here to do that, we better find all asymptotes, poles, and x and y intercepts. So to start with, we better look to see if this function has any holes. Holes when there is a common factor involving an x that you can reduce between the numerator and the denominator. Looking at our numerator, no common factor. Looking at denominator, no common factor. There is nothing we can reduce in this problem. So we know that there are no holes for this rational function. Once we determine that, then we can go on and look to see if there are any vertical asymptotes. Remember, vertical asymptotes are when we reduce away any holes, you set the denominator equal to 0. So what's the equation of our vertical asymptotes? We only have one in this problem, and it's x equals 3. Now we need to look to see if there are any horizontal asymptotes. Horizontal asymptotes we find based on the degree of the numerator and the denominator. So let's look at our numerator. Here, what's the degree? What's the highest exponent on the x? The degree equals 1. And then what about the denominator? The degree also equals 1. So in this case, the degrees are equal. And remember, when the degrees are equal, you have a horizontal asymptote. And the equation is y equals the ratio of the leading coefficients. What's the leading coefficients in the numerator to you? What's the leading coefficients in the denominator? What numbers in front of this x are 1, so it's y equals with 2 over 1, which is y equals 2. So let me write it down. Here are my horizontal asymptotes. X equals 2. Now remember, once you've found you have a horizontal asymptote, it cannot also have a slant asymptote, so we found out our asymptotes. Now we have to find the x and the y intercepts. So how do you find the x intercepts of any function? You said y equal to 0. Remember, in this case, it's f of x equals to 0. So 0 equals 2x plus 1 over x minus 3. When it's a fraction equals to 0, when the numerator equals to 0, so let's solve this subtract 1. From both sides, divided both sides by 2, so I get x equals negative a half, and what is that as an order pair? It is a negative or half 0, that is my x-intercept. Now we need to find the y-intercepts. Remember, you always find the by setting x equals to 0. So what f of 0, wherever you see an x up here, what are you going to put as 0? So you're going to have 2 times 0 plus 1 over 0 minus 3, so that is a negative 1/3. So as an ordered pair, that's 0 negative 1/3, and the only other thing is a useful find. It does the graph cross the horizontal asymptote, that I'm going to abbreviate like that. And the way you do it is you set the function 2x plus 1 over x minus 3 equal to the horizontal asymptote. To see if this is true and what is the simplest way to solve an equation that looks like this, cross multiplies, so 2x plus 1 times 1 has to equal to x minus 3. Running out of room here, so let me write it up here. So I get 2x plus 1 equals 2x minus 6. Subtract 2x from both sides, and if you notice, all your x's disappear and you get 1 equals negative 6, which is a definitely false, so it does not cross the horizontal asymptotes. So now we found all that information. Now we're ready to go on the next slide and actually grab it. So I've input all the information we found on the other slide. On here we go our asymptotes and intercepts and the fact that it doesn't cross the horizontal asymptote. So let's look at the vertical asymptotes. X equals 3, so let's grab the first. Remember, asymptotes are always with the dotted lines. So here is my vertical asymptote. X equals 3, I have a horizontal asymptote of y equals 2. And remember, graphs never ever cross a vertical asymptote. And we found in this case it doesn't cross, it's a horizontal asymptote. Either now I have the x-intercepts of negative 1 half 0, so I started origin and go half a unit to the left, which is kind of hard to do, but it gives me a point about there. Then I need a 0 negative 1/3 my y-intercept. So again, start in the origin and go down about a third of the unit, and I've got my second point. And I think you can see that in this region of the graph, since it can cross the horizontal asymptote, it can cross the vertical one. My graph is going to come in, go through those 2 points, and then approach my vertical asymptote. So we can draw in that part of the graph. So remember, it approach the horizontal asymptote out at the negative infinity. Doesn't cross, it comes down through those 2 points and then approach your vertical asymptote, and again doesn't cross it. So I'm very happy with that happens to the left of this vertical asymptote. But now I've got to figure out what happens on this side. Unfortunately, I have absolutely no points. My two intercept were on the side, which allow me to figure out that I have two possibilities for the graph. To the right of x equals 3, it could start down here and go up here and approach my horizontal asymptotes, or it could start up here and approach it from this direction, and we really have enough information to determine which one is true. Is my graph did this came out and approach from this direction, it would have to cross the x-axis somewhere in this region, but no, there is only one intercept. The graph does not cross the x-axis anywhere there is, so that is not a possibility. So we're pretty sure that graph is going to look like this, and all we have to do is just double check by picking some points to the right of x equals 3, or could pick x equals 4, or x equals 5, x equals 6, it doesn't matter. I'm going to pick x equals 5. So all I have to do is figure out f of 5. So up here is my function. So f of 5 is 2 times 5 plus 1 over 5 minus 3. 2 times 5 is 10 plus 1, so 11 over 2. Since I'm going to graph it, I'm going to write it as a demical as 5.5. So my point is 5 comma 5.5, and is that in the region we thought it should be in. Well, when x equals 5 and y intercepts equals 5.5. This is all for today. I hope you learned something. Bye!